So we had already seen that it took a really long time for life to be created and for the diversity of species to get to where we are today. 8.7 million species managed to evolve as a result of this combination of factors that allow life to be possible on this planet. Then we move on to see how many of these species are declining. This decline is happening around the world, thousands of species, and it's happening despite the fact that countries and people care. And we saw that last class. Today, we're going to move on to what happens next in this pathway of decline. So you think about a species declining, at the end of the decline is extinction. And that extinction is what we're going to be focusing on today. Before we get started on describing extinction, let's find out how a species originates. And that process of origination of a species is what is called speciation. Generally speaking, there are only 4 different ways in which you can create a species. The first way is called allopatric speciation. And basically what happens is you start with a population, right? You guys recall a population is a group of individuals of the same species. Now, something comes along and breaks the population in 2, right? So you can imagine like 100 people living on a place and something comes and creates a barrier now separating one group of individuals on one side and one group of individuals on the other side. Over time, these population that was divided start reproducing among themselves on the different populations that now are separated. And as a result of adaptation to local conditions, these populations go into different evolutionary pathways, and eventually they become different species, such that if these individuals now over time were to come together, they will not reproduce anymore. At this point, you will have created 2 species. That is what is called allopatric speciation. And you see, it went from being 1 species to now being 2 as a result of you creating a barrier. Now, another type of speciation is what is called peripatric speciation, right? In this case, there is a population, and eventually there are some few individuals that manage to escape the population and establish what is called a peripheral population. Most of the species probably that came to Hawaii originally are like that, right? Those species originated somewhere else, most likely in the Central Pacific, in the Indo-Pacific, and some individuals managed to get to these islands. Over time, the individuals on these new populations become very different, such that if they were to come together, now they will not reproduce. Technically speaking, they became 2 different species. A somewhat related mechanism is called parapatric speciation. Again, you start from a unique population. Some individuals find some different characteristics on the edges of that range, and because of reduced gene flow to the edge, eventually that one population becomes 2. The last mechanism for you to create a species is what is called sympatric speciation. This one I find it to be the most intriguing of all of them, because in this case you originate two species from 1 species in the same place. You see, all of the other cases, there was a barrier, all right, that makes sense, it separated individuals. In this case, populations were established somewhere else. But in sympatric speciation, the new species originates in the same place. Now, I want you to pause the video for a moment and think about how can you create a new species in the same place? What kind of processes could create individuals from a population in a given place to become different, right? Take a moment, pause the video, and think about it and see what you guys came out with. Now, continuing on, one mechanism, for instance, in which you can get sympatric speciation is, there are multiple ways actually to get there. One is what is called sexual dimorphism. These are species that for some reason start creating different attributes that makes some individuals more attractive. So because some individuals are more attractive, that means that there are going to be some species that are going to be ugly, and everybody wants to reproduce like crazy. So eventually you will find a species with this sexual dimorphism, eventually resulting in different species. And again, was separated, in this case, the individuals from the original population were attributes of the species itself. Other things that can separate individuals from in a population in the same place is, for instance, the use of the habitats, right? Some species might like higher up in a tree, other ones might like it lower down. You can also think about time, right? Some species might become active at night, some other ones become more active during the day. As a result, in this case, the individuals share the same space, but they have been separated somewhat in such a way that over time they become two different species. Now, depending on the pattern in which a species is created, you have certain geographical range, right? In the case of sympatric speciation, the range doesn't change because the species originate in the same place. When it's peripatric, the range kind of doubles. When it's allopatric, the original range of the species gets cut in half. Eventually, the species is going to go through a phase that is called an interim phase. Right? This is a moment in the evolution of the species in which the geographical range of the species doesn't change, and probably that's the commonality for most species once they originate is they get to everywhere where they can be, and they hang out there on all of those places for a long time, and that's what is called the interim phase. Eventually, there is something that will happen to those species, and they start contracting the geographical range up to a point in which the geographical range becomes zero, right? So when the geographical range of a species becomes zero is when the species becomes extinct. I'm pointing out this, again, it's just the evolution of range size. So how over time the geographical range size of the species changes. Again, it originates depending, the original size depends on how the species got originated. It's going to be a stable phase and eventually it's going to decline. One of the things that I want us to focus on is this contraction phase, right? I want you to take a moment again and think, how will the species become extinct? If the species is found in, say, this geographical range, and extinction is when the species, when that range becomes zero, how does that contraction happens? All right, so there are two ways in which this contraction of the geographical range could happen. One is what is called outward extinction. Basically, what happens is the species start going extinct from the middle towards the edges. So let's just look at that again. So again, you see the individuals start disappearing in the middle, and the last individuals that remain of the species are found on the periphery of the geographical range. That is what is called outward extinction. Again, if the species is found everywhere, the species start dying from within the middle towards the edges, and that's what is called outward extinction. The other mechanism that is likely is what is called inward extinction. It's the opposite case. In this case, the species is found everywhere and individuals start disappearing from the edge towards the center, meaning that the last individuals remaining from the species are found normally in the middle of the geographical range. Now, I want you to pause this video again and think for a moment in nature, what will be the most likely way that the species go extinct? Well, I hope that most of you thought that the species will go extinct inwards, right? Now, the expectation here for the longest of times is that given the fact that the species cannot move outside the bounds of the geographical range, means that there are conditions on that edge that are already lethal for the species. If there were no conditions lethal for the species on the edges of this species, the species will continue to move. So you will think that the populations on the edges of the range are species that are probably not that great. Now, interestingly enough, there was a guy called Chanel and Lomolino, and they decided to test this hypothesis with mammals from Australia. And what they found on all of these mammals from Australia was that almost 98% of the species that went extinct went extinct inwards. These are species that went extinct mostly because of human impacts, harvesting, and we eat them to death, pretty much, these individuals there. But in these cases, these species, almost 98% of them went extinct outwards, meaning that it was from within the center of the geographical range that the species went extinct whenever humans were responsible for those extinctions. So I want you to pause the video for a moment and think about why. Why in nature we will think that the species will go extinct from the edges towards the center, but when it comes to humans, it's the opposite. We start driving a species extinct from the middle towards the edges. The reason why this could be the case, that a species go extinct from the middle towards the edges when it comes down to humans, is that normally in the center of the geographical range is where the conditions are the best for the species. So those are places where individuals get to be larger, populations get to be very abundant, so humans will like an easy catch, right? So it's most likely in the middle of the geographical range where we are going to find the largest individuals and the most abundance, and that's where we are going to be putting most of our effort to harvest a species, and that explains why under human conditions normally we drive a species extinct from the middle towards the edges. Now take a moment to think about the double wang that we put this species under. Okay, think about what else could then accelerate the extinction of a species. Well, it turns out that this way of extinction actually makes the extinction of a species a lot faster, right? On one end is us driving a species extinct from the middle of the range, because that's where the biggest and most abundant individuals are. But on the periphery, the environmental conditions are not suitable for the species. So this is like burning a candle from both ends, right? And that's the reason why species become extinct relatively quickly once humans start impacting them again, is because we eat them in the places that they are the most abundant. The places that remain are not suitable for the species, so the species really just don't have any suitable place for them to propagate. Now, it's important to understand that extinction is not something that is new. It's actually something that has happened for the longest of time. In fact, the estimations of the levels of extinction on the planet suggest that of all of the species that had ever occurred in the planet, that had ever lived the planet, only 0.1% of them live today. 99.9% of them had gone extinct already. Now, here in this figure, this is one of the few papers that are super fascinating because it documents the extinction of a species over time. And you can see here, this is extinction. This is the percentage of all of the species that went extinct at different time periods over the history of our planet. And I want us to focus first in an interesting observation, which is the fact we already know that the life on this planet could be as old as 3.6 billion years old. However, when it comes down to documenting extinctions, we normally go back about 500 million years. So easily for 3.1 billion years on the history of our planet, we just don't have evidence. The best evidence that we had in the history of our planet only goes back about 500 million years ago. Now, these extinctions, though, these patterns of extinctions that we see before, have multiple causes. Some of them have been the result of glaciation, volcanism, methane. We're going to review that in a moment. And then we had the meteorite, which is responsible for the dawn of the dinosaurs, as we all know. Now, an interesting question, though, that I want us to formulate is, why is it that the evidence about extinction is so short? Why only goes back 500 million or so years? So there are different explanations for this. One explanation is that if you look at the tectonics, the plate tectonics of our planet, it turns out that almost everywhere in the planet, these plates go eventually inside the planet and they get melted. In fact, it has been suggested that the average time of the cross of the planet ranges quite a lot, but on average is on the order of 600 million years, right? So we are talking that if you put a coin almost anywhere on the land surface of the planet, in 600 million years, that coin is going to go inside the planet and it's going to get melted. So all of the evidence that we had in the planet pretty much gets borne out, returned. There is a huge turnover on that evidence on the order again of 600 million years. Again, everything that is left on the surface of the planet, any evidence eventually gets put into the inside of the planet because of plate tectonics. They get melted, so all of the evidence goes away. So that explains one of the reasons why the evidence of the planet, the evidence of life on the planet is so short, is because all of the evidence is already gone. Now, another reason for why there is not really a lot of evidence is the fact that, of course, we need something that is capable of leaving behind some evidence. So those are individuals that normally produce calcium carbonate structures. And those individuals, those species, are actually relatively young in comparison by the time of life in this planet. And they started to be created on the order of about 600 to 500 million years ago. So the second reason, again, why there is not really a lot of evidence about the diversity of speciation and extinction of life on the planet is because in the individuals, the species that can live that evidence only came out on the order of 600 to 500 million years ago. Now, if we look at the patterns of extinction in the planet, you will see this is extinction again. You see these peaks. They're on the order of about 20 peaks of extinction throughout this period of time at which we had evidence. But when you look at that profile, there are 5 extinction events that are relatively well defined. Those are called mass extinction events. Those are moments in the history of the planet where up to 75% of the species went extinct. Again, that's what is called a mass extinction event. Moments in the history of the planet when over 75% of the species went extinct. Let's look at some of those extinction events. The first one is what is called the Ordovician-Silurian event. In this one, 60% to all the way up to 80% of the species went extinct. And in this one, it's believed that it was a result of some kind of cooling on the planet. All right, it's actually the opposite of what we see today of what is called climate change. All of this global warming that we are seeing today, in this one extinction event, it was the opposite. The evidence for that is that the level of CO2 in this time came down. How? Well, we just don't know yet, but one explanation could be related to the fact that there were these massive deposits of rocks that took that carbon out of the atmosphere and depleted the concentration of CO2 in the atmosphere. Another explanation for why the planet could have cooled down in this mass extinction event is because of the volcanism. Normally, volcanoes produce CO2, but there might be cases in which the emission of volcanoes actually remove the CO2 and brought down the concentration of that greenhouse gas in the atmosphere, and the planet go cold. When the planet cooled down, the sea level came down. Obviously, a lot of water from the ocean got frozen, put on land, and the oceans came down, and a huge surface area where marine species were used to live got lost. There is also evidence to suggest that there was a depletion of the oxygen in the oceans at that time. And again, that was the first of the big 5 mass extinction events. The second one is they happened on the order again of 380 million years ago. This one was called the late Devonian extinction. 70% or more of the species at the time were extinct, again most likely because of volcanism. This one is the brutal one, right? The third one. I want you to remember that of all of the mass extinction events that have happened in the history of the planet, 5 of them, the third one has been the craziest of all of them. That's what is called the Great Dime. I want you to think about this. At that moment in the history of the planet, 96% of the species went extinct. 96. Shoot, man, that's a lot of species that went extinct at this moment. The reason for this extinction event is believed to be related to volcanism. Somehow, volcanoes start warming up the atmosphere of the planet. As a result of this accelerated emission of greenhouse gases, the planet starts warming up. It turns out that through millions of years of the position of sediments from the land into the oceans, these sediments in the oceans produce methane. And that methane, because of the low temperature and pressure, was frozen. So there was this reservoir of methane, which is a greenhouse gas, at the bottom of the oceans. When the volcanoes warm up the atmosphere, the oceans got hotter, and all of this methane that was frozen there got released. So this is normally what is called a methane bomb, and it created what could be referred as runaway climate change, basically an accelerated increase of greenhouse gases, warm up the entire planet, and then the rest is history. 96% of the species at the time went extinct. The fourth one, well, it happened on the Triassic. Jurassic, again, most likely related to volcanoes. And the last one, which is the one that we all know about, is the dawn of the dinosaurs. That was at the end of the Cretaceous. And we all know that the most likely reason for that mass extinction event was a meteorite. Evidence suggests that that meteorite hit somewhere in the Gulf of Mexico, and it was responsible for the extinction of the dinosaurs. The space that they left behind was used by us mammals to be where we are today. Now we get to today, and the question that we had to formulate is this: are we on a mass extinction event right now? A lot of people is concerned about the loss of species. The species are declining. Some species we have documentation that they are going to extinct, but the question is this: are we at a mass extinction event? Don't forget, a mass extinction event is when 75% or more of the species at the time go extinct. So the answer to this question is no. Okay, we are not at a mass extinction event right now. Unfortunately, we are getting there, and we are getting fast there. Now, as we know, again, we documented already that a lot of species are declining everywhere. But there is this paper by Professor Barnowski from the University of California that took all of these species that have populations that are declining, and he plotted them on this plot. Here on this plot, you see, for instance, the different taxonomy groups and the magnitude of extinction. Again, if you go all the way up to 75% or more, is what is called mass extinction event. And as we established, there are 5 of them: 1, 2, 3, 4, and 5 mass extinction events. Again, periods in the history of the planet when 75% or more of the species went extinct. So Professor Barnowski took all of the species that are vulnerable with extinction today, and some of the ones that are already extinct, and he plotted them here. So what you see here is the number of species that are already extinct in different taxonomy groups. You can see that we're still far from reaching that threshold of becoming a mass extinction event. Okay. Now, one of the things that he did, though, that was very interesting was what will happen if all of the species that are today what is called a critically endangered go extinct. Those are species that are almost gone. There's almost no way to come back. So basically, if you extrapolate these trend lines, you find that by 2050, you are still not at the 75% mark of becoming a mass extinction event. However, one of the things he did in addition in that paper was to look at the species that today are what are called vulnerable. Those are species that are starting to decline, but we can still save. If we were not to pay attention to save those species, he then documented that easily by the year 2100, if those species go extinct, then we will become the reason for the 6th mass extinction event. Again, if you were to extrapolate the decline of many of these species, the ones that are critically endangered today will put us on the order of a 40–50% extinction by 2050. But if the ones that are just beginning to decline today, we don't save those species by 2100, many of those species will certainly go extinct. Let's look at some of these species that have gone extinct. I normally like to put faces. Many of these numbers that we put out there don't resonate with people, and I think it's because we fail to create a connection with these species. So let's just take a moment to check out some of these species. This one is a very famous one. This is what is called the Tasmanian tiger. It lived in Tasmania easily 400 million years, right there on that tiny island. In the 1800s, people came. We went there. The animal never came to us. We went there and we disturbed the habitat of this species. It was a carnivorous animal, so we started eating our animals, and in 200 years we wipe out that species. That species again went from being completely pristine, didn't bother nobody. We went to that island, and in 200 years we wipe out that species. Here's an example. Here is the last one. This is the last guy. This is the last guy of this species, man. Look at that. Just think about you being that guy. You are the last individual left of your species, and you're put in a cage. Oof, man, it just gives me the goosebumps every time that I look at this craziness, man. Again, that was the last individual of that species. Oof, man, that's just cruel, dude. That's just freaking cruel, man. Now, this is what I want you to, another thing that will make this example even sadder. In 1930, somebody took a gun and shoot the last individual of that species in the wild. We had such a good record of this that the last individual that was used to live free was shot in 1930. There were some individuals left in the zoo, right? And the last individual of that species died in September 7 of 1936. We even know the date when the species went extinct, September 7, 1936. The last one. The last one, man. Unfortunately, laws to protect the species came out in 1936. Can you believe that craziness, man? This species is coming down, it's at the brink of extinction. The last one died in 1936, the year that we decided to put the laws in place to protect the species. So unfortunately, as I explained last time, help came out too late. That's a very common thing for many of these species. Let's look at another case example. This is what is called the Western black rhino. This species was used to live in Africa for easily 50 million years. This is the original geographical range of the species. And we humans, for some crazy reason, we started to like the horn of that animal. I mean, what is crazy with us? How are we going to take an entire animal just to get the horn out of it? It's just brutal, crazy. It turns out that humans, we like to give value to the horn of this thing. Every kilogram of that thing is worth up to $60,000. In a place, in a continent where there is so much poverty, you can imagine what it will mean to kill just one of these rhinos. So it turns out that in just 40 years, we wipe out that species. Again, that species was used to live for 15 million years in Africa. We came along, and in just 40 years, we wipe out that species.
We're extremely worried about today's news. To hear about the extinction of a subspecies from West Africa is a grave concern, and we have grave concern for the rhino more generally. Illegal trade in wildlife is now estimated to be worth around $10 billion per year. This is driving many species to extinction. It's also robbing local people of their livelihoods, and it's also perpetuating fraud and criminal activity, and it also robs countries of their cultural and natural heritage. And I think when you look at a species like the rhino, that's, if you like, the mega fauna of the world, it's such an iconic species. If we can't save the rhino, how on earth are we going to save species that are of much less public interest?
Let's look at another case example. This is what is called the golden toad. This species was used to live in South America for 65 million years. I mean, just think about that, right? That species calls home South America for 65 million years. Then because of this issue of us creating all of these greenhouse gases and making it hot, it turns out that we're making many diseases prosper under these conditions, and many of these diseases, unfortunately, are killing these frogs. Unfortunately, this one went extinct in just 30 years. So the species, again, was used to live in Central America for 65 million years. In just 30 years, the species went extinct. And in this case, it was not even because people got there, but because of the things that we do everywhere else, created a climatic change that enhanced the production of fungi on those places, and the entire species went extinct. The species was declared extinct in 1992. And those individuals that you see there are probably one of the last footage that we had of that species being alive. This is another case example. This is the Caribbean monk seal. This species, who knows for how long, but it was used to live in the Caribbean Sea. And originally, it was established that the population of this species was easily on the order of 250,000 individuals. There are records when Christopher Columbus arrived in the Caribbean Sea of this species covering entire beaches and rocky cliffs, just for you to get a picture on how abundant this species was. again, for those weird things of us humans, we started to like not even the meat, but the fat of that animal to burn candles so that we can see at night. And basically, the entire species went extinct in less than 300 years. So since the arrival of the Spanish to the Caribbean, that marked the beginning of the end of that species. 300 years, the species went extinct. Again, went from 250,000 individuals to 0 individuals today. The last sighting on this species was in 1952. Again, 1952. Yet, the law to protect the species was introduced in 1967. Again, this one time we are like decades after the species went extinct. And to make matters even sadder, the species was declared extinct in 2008. So we humans, we just don't seem to care at all about this species. Again, this species most likely went extinct back in the 1950s. We introduced regulations to protect it in the 1960s or 70s, and we finally cared to declare the species extinct in 2008. Again, just for you to realize that we are always seem to be getting late to save this species. Here is another species. This one went extinct in 1981. This one went extinct in the 1970s. This one extinct in the 1970s. This one 1989. This one extinct in 2000. This one 2003. This one went extinct in 2004, 2008. I can spend hours here flashing images to you of all of these beautiful species that were used to call planet Earth home, and given our indifference and our selfishness, we wipe them out. Easily 20,000 species just like these ones could be gone extinct every year, 20,000 of them. Now, unfortunately, we always seem to be late at classifying species extinct. If we manage to say species are extinct, potentially we could get more concerned about this. Unfortunately, as scientists, we had a hard time declaring a species extinct. Let's look at why is it difficult for us to document that the species are extinct. It's real. So, unfortunately, it is very hard for a scientist to claim that a species had gone extinct. If we were lucky enough to be able to say species are extinct easily, I think that a lot of more people will be concerned about this. Unfortunately, as scientists, there is a big fear, and you will see that the fear is well deserved, had a big fear of declaring species extinct. Let's look at the challenge why scientists had a hard time claiming that a species go extinct. Unfortunately, as you can imagine, one of the things that happens when the species is declining is that the individuals become rare. So if the individuals are rare now, few here and there, it becomes very hard for us to find them. So it's very likely that we might not see the individuals, not because the species is extinct, just because the individuals have become very rare. Here is an example of this. So this species here is called the Yangtze River dolphin. This species, as you can see, was used to live in China, and because of multiple disturbances in the rivers in China, mostly the creation of dams for generation of electricity, and the fact that rivers were digging to get boats into the mainlands, the habitats of this species disappear. And scientists found that the last individual seen of this species was 2002. The species was almost declared extinct in 2006. Scientists needed to declare this species extinct so that they could put a break on all of the development that was happening on these rivers. Unfortunately, back on those days, just in 2006, as they were about to claim the species extinct, somebody came out with a video, I believe, or a photograph of something coming out in a river that looked just like the dolphin. As a result of that, it's believed that, again, this species might still be hanging around there, despite the fact that the last time that we really saw one for good was 2003. So here you can see again the challenge that we had with declaring species extinct is the fact that, again, as the species start declining, they become very rare. The individuals, we don't find them, but the fact that we don't find them doesn't mean that the species is extinct. It's just that we don't see them. Now, so when do we declare then that the species is extinct? If we don't see them anymore, when do we make the call, okay, this is it? It turns out that some people have made an analysis into this. This is a paper done by Professor Solo looking at the dodo. This bird was used to live in Mauritius, a tiny island. It just got there, isolated the species. The bird stopped flying because it didn't need to fly, and there were no predators, so it got to be very big. And the species was pretty stupid. They call it the stupid bird, because when the sailors arrived to this island, the species was used to come to people, and people were just cutting their heads off and eating them, and the animals were just coming to their death. Eventually, the species went extinct. The last time that there is a record of this species was 1662. Now, again, as I explained, unfortunately, the fact that you don't see them doesn't mean that they are extinct. So this is an analysis again done by Professor Solo. This was published in the journal Nature. What he did, he took all of the records of when the species had gone extinct. Sorry, when the species was seen. So if you look at the logbooks of sailors from back on those days, they went and collected all of those days, and those are the times when the species was seen. And again, the last time that the species was seen was in 1962. So what they did, they create a density distribution that allows you to extrapolate eventually, given the last time that we have seen it and the frequency in which those sightings occur before the species went extinct, allows you to predict when the species will become extinct. Given this analysis, they established that the species likely went extinct in 1690, 30 years after the species was last seen. And again, this is again another sad reminder that we might not rely on extinction for us to take action on a species, because the reality is that we might have to wait 30 years for declaring a species extinct. So all of these species that we see now at the brink of extinction, they can just not wait for us to go out together to save them based on extinction alone. We just cannot rely on extinction as an indicator again to protect the species, because the reality is that scientifically we will have to wait 30 years. According to Professor Barnowski, you recall the paper that I showed earlier, in 30 years time, easily 50% of the species could already be gone. So people, instead of declaring a species extinct, have come out with rather an alternative way to highlight the crisis that many species are under, and that's what is called the probability of extinction. This was introduced by Professor Nick Dolphin in that paper there. And basically, it's a mathematical equation. Again, it's calculated, is referred as P, probability of extinction. And basically what it is the total number of intervals in which the species have been sampled divided by the total number of the time since the last sample divided by the total number of years that the species was seen. So again, I don't really want you to focus too much on the mathematical equation. All what I want you to know is that the mathematical equation basically is based on, again, the number of times that the species was seen in relationship to how far back the species was last seen. And from that, you can calculate the probability of extinction. He applied this mathematical equation to this one species here, the sturgeon. It's a freshwater fish, and basically, according to this calculation, there is almost an 85% chance that that species is extinct. Again, according to given the fact that the species was last seen in 1994, and given Professor Solo that we had to wait 30 years to declare the species extinct, this guy rather said, you know what, there is an 85% chance that the species is extinct. So this is again trying to highlight a different indicator that will reveal the danger of many of these species. This is what is called the probability of extinction. This is another indicator of extinction. Again, rather than getting to extinction, let's see how far are we to get there. This is an indicator done by Christine Warpage. She's a close friend of mine from the Hawaii University, and she came up with this index. I was co-author on this paper with her, that we call the time of extinction, the time to extinction. This indicator was applied to all of the sharks in the Caribbean. And basically, the way that it works is you calculate the sizes of the populations today, and you manage to monitor the sizes of those populations over time. you analyze the time that it takes for the individuals to grow and to reproduce, you can get a sense of the level of replenishment on those populations and compare that again with the levels of fishing, and that allows you to then figure out how long will it take for the species to go extinct. And again, that's what is called the time to extinction, and it's basically trying to figure out how long do these species have left for them to exist. In the case of the Caribbean, all of the species of sharks in the Caribbean, actually almost all of them with the exception of maybe a couple, are projected to go extinct within the next 10 or so years. Again, the rates of mortality of these individuals on those places is much, much higher than the rate at which new individuals are created, and it creates an imbalance such that the populations decline, and at this pace they could easily be gone in the next 10 to 20 years. Now, if we go back again to the historical record, we already know that here in the upper figure we see extinction, and we see our 5 mass extinction events, 1, 2, 3, 4, and 5. You can also look at the historical record to see the intensity of origination on a species, speciation, right? Just to see if there are peaks in which species the diversity of life prospers on this planet. And one of the things that is remarkable of the historical record as well is that for every mass extinction event, there has always been a mass origination event. Again, you see a peak of extinction here in the first extinction event. Here is the peak of origination. Here is the Great Dime. Again, 96% of the species went extinct. It coincides with a peak of origination, and it was the same thing with the last mass extinction event. Again, huge amount of species went extinct, but some years later, the planet managed to heal. Now, what is interesting from the historical record is the time that it took the planet to recover, right? The healing. The planet, life is marvelous. I mean, they get hammered, but they bounce back. The question is, how long did it take for life to recover? In this one paper, again by Kirchner and Will in Nature in 2000, they found that it took about 10 million years for life to recover from those mass extinction events. So when we think about the extinctions that we are doing to our planet, there is not going to be a magic pill that is going to bring back those species. In fact, it could take easily 10 million years for those species to come back, given the precedence that we already had in the historical record. Now, so what? Species go extinct, by which are the planet with those species at the moment that those species go extinct, and we had already seen that we humans use a lot of goods and services from nature. So is there any example that we can think of what will happen to us if we drive all of those species extinct? Unfortunately, there are just not many examples of what could happen to us, but there is one example of the fate of humanity when we drive a species to extinction, and that one example is what is called Easter Island. So a tiny island in the middle of nowhere in the South Pacific. That island was colonized sometime by Polynesians, sometimes 300 to 1200 before present. And we got there, and that island was used to be colonized by many species of plants and birds. Here is the number. Easily 21 species of trees and multiple species of birds on land were used to be found on that island. Unfortunately, a couple of things start happening on that island as we arrived there. For some weird reason, we started to make these humongous structures begging to God for help because we saw the end coming, right? Unfortunately, what we failed to realize is that by us asking for God for help, what we were doing was cutting down the trees so that those structures could be built. So on one end, these species, the trees, the adult trees, were being cut down for maybe to build these, but also perhaps to build houses and things like that. But on the other end, it was the introduction of the rats, and the rats were eating the seeds of many of these trees. So you can see how the life cycle of these plants on this island were hammered on both ends. On one side, it was us cutting the adult trees, and on the other side were the rats eating the seeds. So it didn't really take too long for the entire diversity of species on this island to be cleared out. Now, what happens next is what is interesting for us. Again, almost all of the species on land went extinct. And one of the interesting observations of the human population on this place is that if you see the profile here on this lower figure, this is the approximate number of people on Easter Island. And you can see how the population of this island started very small, and it went easily all the way up to 10,000 individuals. 10,000 individuals of people were used to live on that island. As soon as the extinction hit, it was found that there was nowhere to go. The people were trapped on this island, and unfortunately, they couldn't go and even feed themselves from fish because there were no boats that they could build because they destroyed the trees. So they were trapped there. The fishes were just showing the fingers to these people because, despite the fact that the people wanted to go and eat the fish, they just didn't have a mechanism to go and get the fish. So starvation started kicking in. Again, there was no wood to make boats. Basically, that means no fishing. You were stuck on an island, so there was no escape. They ran out of food, and eventually, people was put on this position when they start eating each other. These bastards ate each other, man. And again, there's no criticism point out here, but this is one of those very few case examples that can point out what happens to us when we start destroying the planet. Now, what the people of Easter Island did to their place is exactly what we are doing today to the entire planet. We're now doing it at the scale of the entire planet, wiping out species like nobody's business. The summary of this class is that extinction is seriously forever. Again, once a species starts hitting that brink of decline, and if it goes extinct, there is nothing that will bring back that species. That finished the class for today.